Okay, so I ended up putting the plate assembly back into the box and put the original M6 screw here. And actually I did use the original M6 by 25 screw here, but I had to remove the washers because it was too short. And the next screws that I have were too long. So again, same screws here. Here I actually used washers here, and then the other two screws were the same silver ones as before. All the connectors are back. Okay, radius 90 here, a straight here, so that's the input signal. Hittite. I put the cover back for the Hittite. I guess you could traverse through Krytar, a 10 dB slope equalizer, MyTech amplifier, Krytar, Condet 2, and the final output, I'm going to a power meter right now. And I'm going to connect up. I just wanted to show that we normally clean the connector before we put it back. So we have one of these top cleaners. So it's very easy. You just open it, put it on, you twist it, slide, twist, slide, and then close it. You use it once only for each swipe. And then I'm going to feed this under here. Make sure the key is facing me. And install. Okay, there we go. And the assembly is complete. And we'll begin testing. So we're going to do basically repeat the same test we did earlier at the very beginning and characterize the after performance. So again, we're going to do all the attenuation steps and the sweeps, the RF sweeps. Okay, so now we're connected back to the noise source, and I have the attenuation set to 13 dB, and that produces minus 28.8 dBm at the input to the connector there. And I have a power meter connected to the output, and still have the 3 dB pad here. And I set the control voltage for the Hittite to 2.42 volts, which is what produced plus 10 dBm in the past before the modification, and now we have plus 6.8, so plus 7 almost. So we're about 3 dB short gain compared to what it was before. And that was even after removing that 3 dB pad that was in here before. But now we have a slope equalizer that has more loss than just that 3 dB pad. So I'm going to remove this 3 dB pad so that we get back to the stock gain profile, even though we have slope emphasis here. So let me do that. Okay, so I did remove that 3 dB pad here, and still at 2.42, and now we have almost plus 10 dBm here, but I'm going to change the target value to be plus 12 dBm. So let's go do that. I'm doing that by lowering the control voltage. So in essence, I'm driving the transmitter 2 dB higher in power than the stock condition. Okay, here we go. We're at plus 12, and the new control voltage is 2.16 volts. So I'm going to do the entire recharacterization of this table. Didn't do it yet, but I will. I'm going to update it. So that's today's date, September 3rd. And actually, before I do that, I'm going to make sure that the continuum detector voltages are okay for this level. So we have 8.7 volts for content 1, 6.4 for content 2. I'm going to try to make them similar in value, so I'll put a 1 dB pad in content 1, so that'll be a pad before this, and probably remove a pad. Right now, remember there's 10 plus 8, so I'll remove 1 dB from that just to make them closer to 7 volts. See what happens. Okay, so I did go ahead and add, actually I removed 1 dB of padding here, and I had to do that by using a 6 plus 1 dB to get 7, because there used to be an 8 dB pad here. That's still a 10 here. So that's condet 2, and then I added a 1 dB pad to condet 1. And so I have to check this really good because the IF assembly is warming up slowly, and so it's dropping gain. Okay, so we're at 12 plus 12. Normally you have to wait about 10-15 minutes. Okay, so here's 12, and content 1 is 7 volts. Content 2 is 8.2. So what did we have before? So for 13 dB attenuation, we had 6.85 and 8. So it's very close, okay? So I'm gonna leave that as the values, and of course I have to update content pad to 1 dB and then a 10 plus 6 plus 1, okay? And then the fiber optic pad is 0 because I removed that. And then of course the 2.42 is now a different number, and plus 12. So I'll update all that. I'm gonna fill in this entire table. I'm also gonna take CSV plots for 13, 16, and 19 dB attenuation, also terminated. And the spectrum analyzer noise floor should not have changed, so I'll leave that as is. So be back. Here's a plot of the frequency response of this particular module, serial number 005, prior to modification. And this is the plot after modification. And I'll go through and explain the different colors here in a little bit more detail. So the top dark blue trace simulates a condition where an ambient echo-sorb load is placed in front of the receiver cartridges, and it represents 300 Kelvin noise temperature. And the gray trace below the orange trace represents sky. So there's about a 6 dB difference. It's an exaggerated difference. Typically we see a little bit less than that, maybe 5 dB, 4 dB type Y factor. And the amber trace in this case represents the system noise floor generated by the IF assembly. So that would be with the input terminated with 50 ohms. And the very bottom blue trace represents spectrum analyzer noise floor.